Welcome back. This is lesson 4.6. We're going to talk about unit rates. For this one, I actually want you to pull out your calculator because we're going to look carefully into wording, and some of the division's going to get a little nasty on here. So have your calculator out to use for this one. Alright, this says, I will be able to correctly find and use unit rates to find missing values for real-life situations. I will be able to find the unit rate for any situation. Okay, vocabulary for this lesson is a ratio. We already have learned that a ratio is comparing two values by division. A rate is a ratio with two different units. A unit rate means for exactly one of a certain unit. And a proportion is setting them equal to each other to solve for missing values. Alright, we have some different situations here. We need to pay really close attention to the wording. Okay, so for this situation, it says, it takes 20 minutes to fill a 40-gallon drum. So what are we comparing here? Here, we want the gallons per, that means for one. So I want the gallons per minute, or the gallons for every 1 minute. So for every 1 minute, we want to figure out how many drums get filled. So we have our rate, which is gallons per minute, so that would be 40 to 20. But for a unit rate, that means I want for 1. So I want my minutes to be 1. So what do I have to do to 20 to make that 1? Okay, I'm actually going to divide by 20. That means I have to divide 40 by 20 to figure out how much we would need. So 40 divided by 20 is 2. So there are 2 gallons to every 1 minute. So under here, my statement is for every 1 minute the drum filled 2 gallons. There is a unit rate of gallons per minute. 2 gallons per every 1 minute. Now what if we switched it around? This unit rate is asking for minutes per gallon. Now I'm comparing minutes 20, 40. But now I want for 1 gallon. If I want for 1 gallon, what do I need to divide by this time? This time I'm dividing by 40. So if I divide 20 by 40, 20 divided by 40, this is where you can go ahead and pull out your calculator. Some of you already can do it in your head, and that's great. But 20 divided by 40, you're going to get 0.5, or 1/2. Think of it this way, 20 over 40. Do you see how that would reduce to 1/2 of a gallon? For every, 1/2 of a minute for every 1 gallon. So, for every 1 gallon, it took half, or 0.5 minutes. You can write it either way. But I want you to understand the difference. This one said gallons per minute. So for 1 minute, we filled up 2 gallons. This one says minutes per gallon. So we had to divide to get 1 gallon, which is why it took half a minute for every 1 gallon. Okay, now you can see here that I end up just dividing by whatever the second one is. So really, when I'm finding a unit rate, you're just going to end up doing this divide by that. Same thing here. We did minutes, divide by gallons. Look, 20 divide by 40. So for these other ones over here, just remember that we're just going to be dividing by so that we can get 1 hour. or 1 minute. So for this one it says, for 8 hours of work, Sasha earned $96. I want to know her dollars per hour. So for every 1 hour, how much did she earn? So we had $96, and we're going to divide it by the number of hours. So 96 divided by 8 would be $12 per 1 hour. So my statement, for every 1 hour, Sasha earned $12. Now this one's stated differently. Hours per dollar. I want to know how many hours she works for every $1 she earns. So I'm going to be dividing hours by dollars. So she worked for 8 hours, and I'm going to divide that by the number of dollars she earned. Okay, this is where your calculator is going to come in. This one isn't so nice. So 8 divided by 96. 0.833333333. Okay, this is a repeating decimal. So we're going to round it to the nearest thousandth. So we want to know how much of an hour she worked. I'm going to round it to the nearest thousandth. So tenths, hundredths, thousandths. Find your place, look next to our 5 or higher, raise the score. So she worked 8/100ths of an hour, or 83 thousandths of an hour, so not even 10 minutes, for $1. So for every $1, Sasha worked 0.083 hours. Now, do you understand how that is different than this one up here? Dollars per hour I want for 1 hour. Here I want for $1. Okay, let's try this one. Sean's car used 14 gallons of gasoline to travel 448 miles. Miles per gallon. I want to divide this by that to find out for 1 gallon is what that means. So the number of miles was 448, and I'm going to divide that by the number of gallons of gas. We have our calculator, so 448 divided by 14 gallons of gas. So for every 1 gallon of gas, he traveled 32 miles. So that'd be 32 miles per gallon. So for every 1 gallon of gas in his gas tank, his car could travel 32 miles. This one's worded differently. This one says gallons per mile. I want to know how many gallons of gas it burns for every mile that they travel. So remember, gallons divided by miles. We've got 14 gallons of gas, and I'm going to be dividing that by 448 miles. So how much gas did it take to go 1 mile? That's what we're trying to find out. This is going to be ugly. That's why we'll use the calculator. So 14 gallons of gas divided by the 448 miles. Gallons per mile. And we get this lovely decimal. We're going to round it to the nearest hundredth in this case. So the hundredths place is the 3. So find your place, look next door, score. So 1 is below 5, so I'm just going to round this to 0 and 3 hundredths. So it takes 3 hundredths of a gallon for every 1 mile traveled. So for every 1 mile, Sean's car used 3 hundredths of a gallon of gasoline. All right, another place that you might use this in real life. I use this all the time as an adult having to go grocery shopping. I want to make the most of my money. So, Rachel is comparing prices for her favorite shampoo. There are 3 sizes available at the grocery store. Which one is the best buy? In other words, which one costs least per ounce? Okay, right here. Per ounce means for 1 ounce. So we have a 9 fluid ounce for $2.88, a 15 fluid ounce for $3.90, and a 21 fluid ounce for $5.88. So which of these is the best price? So we'll try. So if I want price per ounce, I'm going to take my price. So I have the first one, which was $2.88, and I'm going to divide it by the number of ounces I have. And then we're going to round it to the nearest cent. So you can use your calculator. $2.88 divided by 9. How much money per ounce? That would be 32 cents per ounce. So the first one is 32 cents per ounce. So for every ounce that you're buying, if you plan on using all this shampoo up, you might as well make the most for your money. That one's going to cost you 32 cents for each ounce that you use. Now the 15 fluid ounce, so let's call this one number 2. We take the price per ounce, which means divided by the ounces. So $3.90 divided by 15. So $3.90 divided by 15. You could do this by hand. I'm using the calculator just to speed up our notes, but you can divide decimals by numbers. Okay, we get 26 cents per ounce. So of these two, I would rather pay 26 cents for each ounce than 32 cents for each ounce. So at the moment, number 2 seems like the best buy. Let's check out the third option. So number 3, our price per ounce. So I'm dividing the price up by the ounces. And this one's 21 ounces. So $5.88 divided by 30. Let's start that over again. $5.88 divided by 21 ounce is going to give us 28 cents per ounce. So there's an old saying that goes, the bigger buy is usually the better buy. That is not always true. So here, if I buy the big one, if I need a lot of shampoo, that's great. But if I need a lot of shampoo, why not buy 2 of these smaller ones and spend less per ounce? So which one is the better buy? The 15 fluid ounce bottle is cheapest. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on your Google Classroom Passport.